Welcome. On the map, you see the main tectonic plates forming the outer part of the Earth and the narrow intervening zones characterized by strong deformation. Today, we will focus on divergent margins. Divergent margins are zones where the two lithospheric plates move away from each other. Typical divergent margins are in the South Atlantic, separating the South American plate from the African plate, and in the East Pacific, where the Pacific and Naxa plates move away from each other. The East African Rift is a zone of extension which, given sufficient time, will develop in a divergent margin. Divergent margins are zones where the two plates move away from each other and form a belt of submarine ridges thousands of kilometers long across the entire Earth. The space created by the movements of the two plates away from each other is filled with new magma from the asthenosphere. Volcanism is indeed one of the characteristics of oceanic ridges. Divergence and rise of magma are associated also with widespread earthquake activity along the plate margins. Earthquakes are generally not very large and generate at depth shallower than 5 to 10 kilometers. Divergence margins begin with the onset of extensional faults breaking a continental plate. The structures formed are called continental rifts. The East African Rift, which runs for thousands of kilometers from the Red Sea to Southern Africa, is one of the best known examples. Ethiopia, Kenya, and Tanzania are moving to the east with respect to the main body of Africa, forming a zone of extension flanked by normal faults. A rift is a sinking zone flanked by normal faults. The domain moving downward is called the graben. It is an area of increased accommodation space where sediments can be deposited. These sediments are called syn rift deposits. The region flanking the graben are called horsts. It seems that the first human beings highly appreciated the East African Rift. Lucy, considered to be the mother of all human beings, was born and she lived here. Rifting begins with the activation of normal faults associated with crustal thinning and the consequent subsidence of the central graben. With persisting extension, displacement along faults increases, more subsidence occurs in the central domain, and a thick package of syn rift sediments is deposited. In some cases, extension ends and the continental rift becomes extinct. If subsidence continues, new accommodation space is created, in which sediments are deposited, which are not cut by normal faults. These are called post-rift sediments. This is the case, among others, of the Viking Graben between Norway and the United Kingdom. In other regions where divergence does not stop, the crust and the lithosphere become increasingly thinner. When lithospheric thicknesses of 20 to 30 kilometers are reached, the lithospheric plate breaks, and the initial continental plate is now split in two plates. A divergent plate margin is created. Driven by decompression melting, large quantities of magma are formed, which fill the space being progressively created between the two plates. From this moment onward, the divergent movement between the continental masses will be taken over by the divergent margin. Faults in the continental domains will not be active anymore, and the margin has become passive. As the two plates keep moving away from each other, the new oceanic crust will also move away from the mid-oceanic ridge and will cool down. With cooling, it will become denser and gradually sink and increase in the depth of the ocean floor. Because oceanic crust is generated only at the plate margin, the age of the crust will increase moving away from the ridge. The older the oceanic crust, the heavier it is, and deeper is the seafloor at that locality. The map in the picture shows with different shades of blue the depth of the ocean floor. If you take the oceanic ridge running along the Atlantic, you see how depths increase away from the ridge itself, in accordance with the principle mentioned in the previous slide. If you would then compare this map with maps indicating the age of the oceanic rocks, you would see how regions with deep seas are floored by old segments of oceanic crust. Away from the oceanic ridge, the oceanic crust passes to continental crust, which has been stretched during extension, which preceded lithospheric breakup. These are passive continental margins. Here are the most important features for you to remember: normal faults, syn-rift sediments, and post-rift sediments. Let us now make a summary of the evolution of divergent margins. Before rifting starts, the crust has a constant thickness, and the Earth's surface is typically close to sea level. With the onset of rifting, normal faults are created, which cause crustal extension and subsidence in the central domains. This is the syn-rift stage, and associated with thinning of the crust and of the lithosphere. If extension ends at this stage, a continental rift is created. The North Sea is a famous example of a fossil continental rift. If extension continues, the lithosphere becomes so thin that it can break, leading to a formation of a passive continental margin. Between the two fragments of continental crust, progressively younger oceanic crust is formed.